These next two examples are going to get us thinking about independent versus dependent events. And so for the first one, suppose you have two dice and you're interested in the events, observe one on the first die and observe one on the second die. And you want to know if those two events are independent or if they're dependent. So to think about that, you can ask yourself, okay, so if I were to roll those two dice on separate tables, does the outcome on the first dice, or on the first die, affect the outcome on the second one in any way, shape, or form? Or can I reverse that? Does the second dice have any effect on the first one? And the answer to both of those questions would be no. And so here, the answer to our question would be that these two events are independent because those two dice do not affect one another at all. Okay, so I'm again going to go back to example A, but this time I'm going to determine whether or not the events male and in favor are independent or dependent. And so to do this, I'm going to compare the probability of one person being in favor to the probability that one person is in favor given that they are male. If these two probabilities are equal, then what this is saying is that basically it doesn't matter if that person was male to begin with, right? And so if this statement is true, if these two probabilities are equal, then I know my events are independent. And so here I've already found both of these probabilities in earlier examples. So the probability that one person was in favor was equal to 0.19, but the probability that somebody was in favor given that they were male was 0.25. So these events are not independent, which means they are dependent. And so real quick, I just want to point out, I could have also looked at these two probabilities, the probability that somebody's male and the probability that somebody's male given that they are in favor, but I had already found this probability in an earlier example.